From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. We're back again together, Kaushik. How you doing?
I am doing good. Yeah, it's almost long time no here, as they say.
Does everybody hear that? That's Kaushik. He's back.
Yeah, I've been hopping in and off for some time, but yeah, I am super excited to be back. Mostly because I get to talk to you, Don.
Stop. Well, one of the reasons we are back, though, is because you actually were able to connect us with someone very interesting that you work with that has been working on a cool project recently that I had a lot of questions about when you first told me about it. And then as I started taking a look at some of the information about it, the documents and so forth, it just seemed like it'd be a very interesting person to talk to and an interesting project. So I was wondering if you wouldn't mind introducing who our guest is today for the listeners.
Absolutely. So the idea is, even I was, the person we're going to talk to is like one of the smartest Android chaps I've worked with, super passionate about Android. I have the good fortune of having him as a colleague who works with me at Instacart. I'll let him do his own intro. I don't want to make him, I don't want to embarrass him too much. But the reason I was excited about this is because initially when he and I were chatting at work, he mentioned that he's been working on something on the side that he's really excited about, and he built it up. He never told me for the longest time, and he almost got me really excited for a week or two. And when he told me, initially my reaction was wait, what? Mm-hmm. And I'm pretty sure that was your reaction as well too, right, Don? But as we got talking about it, it seemed like a very good idea. And obviously I'm a little biased, so I'm going to let Don do his thing and try to poke holes. But I know this is, I'm very excited just to see, just to have this revealed in a big way. But before we get into all of that, let me welcome my good friend Colin to the show. Hey, how's it going, Colin?
Hi, long-time listener, first-time caller. Thanks for having me on the show.
It's a pleasure. So typically, the way, if you've listened to the podcast before, what we do is we start off by asking folks to introduce themselves, because obviously I know you. Don knows of you a little now, mm-hmm. but basically our listeners probably don't know you. So can you give us a quick intro, how you got started with Android development? And let's take it from there.
For sure. So for those who don't know me, I'm an Android developer at Instacart. I also work on the customer application. We have two separate applications. So Kaushik works on the shopper application, and I work on the application facing customers. I started Android actually in my last year of university. I kind of realized, I need a good marketable skill to get my first job out of university. And I also realized I really wanted to build things for my friends that they could easily download. And at the time, I had an Android phone and I knew Java, so it was kind of just a match made in heaven.
That's very cool. So when I don't even know where to kind of start here. I mean,
where to dive in?
Yeah, exactly. Let me say this. So the reason again why we had you on this, or we have you on the show right now, is to talk about a image loading library that you've created. And to be 100% transparent, when Kaushik told me about this, I kind of, if you could had a camera looking at me while I was looking at the screen reading his messages, you would see my head kind of turn sideways. What? Why is there another image library being created? This is a solved problem. So initially, and I want to ask that question first, because just get that right out of the gate, because anyone who's read the title of this podcast and is now listening to it is wondering that exact thing. So kind of what was the impetus and what was the reason for thinking, you know what, I'm going to create a new image loading library? Was it you felt the other ones weren't sufficient enough? Was it just something you wanted to experience? Or what was it in general?
That's a great question. I think even when when I bring up the fact that I've built an image loading library to non-Android developers, kind of web developers, they also have the same initial reaction where they're just like, isn't this a solved problem? What's there to do with loading images? But I think it is partly that I wasn't fully satisfied with the existing solutions. As well, as we all know, Google announced that Android is moving to be Kotlin-first, and none of the existing image loading libraries have any Kotlin code whatsoever, or even have extensions to support Kotlin users. And I felt that that was something that could be really improved on. And then furthermore as well, I was really excited by Kotlin coroutines. I think it's an excellent way to create performant applications that require a lot of asynchronous computation. Coroutines have really strong support for concurrency as well as cancellation, which are very important for things like image loading, where you have these relatively intense disk I/O and computation tasks that all need to run independently at the same time. So I don't know if I've mentioned the name yet. We made it this far into the podcast, but the library is called Coil, and it actually stands for Coroutine Image Loader. So Coil treats coroutines really as a first-class citizen of the API, and I think this is something we've seen Google kind of very quickly adopting. So if you use, for instance, many of the Android X libraries, the KTX libraries import coroutines just as if it were part of the language natively. Mm-hmm. And
there's also something I want to quickly interject. There's also something about the name that I thought was very interesting, because it sounds coroutine image loader sounds like a very boring name. No offense, Colin.
It's okay. I actually didn't come up with the name. Shout out to my dad who actually came up with the name.
Nice.
So tell us why. So there's also a very interesting aspect of this, and he's too embarrassed to say this out. But I'm gonna straight up bring it up because I can do that. The punching gloves are on. If you notice, it's very similar to his name. So I was like, wow, because his name is Colin, Colin, and the name of the library is Coil. I was like, wow, Colin, really?
I swear it's a coincidence, 100%.
Yeah, we're actually changing the name of the podcast to Felker Gopal.
Yeah, I know, exactly. Just because.
Very matter of fact.
Yeah. But that's I believe him, and he says it was a coincidence because he's Canadian and he's a good person. So.
Oh, he's Canadian. I don't know. I'm just kidding.
Especially after that basketball game, I don't trust these guys anymore.
Oh boy, still salty.
It's getting heated in here. So, if I had to give a synopsis, you're basically saying that the existing image loading libraries, were kind of older, maybe even archaic in the fact that they weren't modern with Kotlin, didn't have Kotlin-first features, and you wanted something that kind of felt more natural in the Kotlin environment. Would you agree with that?
Definitely. I think there's also more to it as well. So Coil is Kotlin-first, but I also really wanted to rely on libraries like OKHTTP and OKIO, these very strong networking and disk I/O libraries that I think pretty much every Android developer is using nowadays, as well as I wanted to rely on some of the architecture components. This is something that none of the existing image loading libraries really use because they were written back in 2013, 2014. So specifically, I wanted to rely on Android X lifecycles to be able to automatically start and stop requests based on lifecycle state. And yeah, I don't know if people are aware of this, but Glide actually uses a retained fragment to kind of track lifecycle state at the moment. As opposed to now you can just register an observer.
Isn't Glide by Facebook, or used to be, or Bump or something like that now Facebook now owns? Is that what it is?
Glide, I think, was by Bump Tech, but I think, and there is some association with Google, I think, or maybe Google unofficially said, hey, use this. This is a pretty decent library right now. Facebook has a different one. That one's Fresco or Frisco.
It's Fresco.
Or But Colin would probably know this. Is it Fresco or Frisco, or It's Fresco, right?
Yeah, it's Fresco. So Fresco is made by Facebook. Picasso, of course, is made by Square. And then Glide is maintained by someone who now works at Google, though I don't believe it's an official Google product.
Got it. I see. That's the relation. Yeah.
So that brings up a good point. Is like, what are our existing image loading libraries out there? So we've already covered, the one that I always default to just because it's the one I've used longest is Picasso. And then, of course, we got Fresco, there's Glide, I think there's Universal Image Loader, and then there's probably a handful of other ones.
Mm-hmm.
We have all these other existing libraries out there. And when you created Coil, what was something that you wanted the developer experience to be that the other libraries were not supporting or providing?
Yeah, so I wanted to... So I think the main two libraries as I see them are Picasso and Glide. Picasso is a very simple library. I think it has like maybe 6 times or 5 times less code than Glide, and it also supports less. So for instance, I don't think it tracks the lifecycle state, as well as it doesn't support bitmap pooling, which is a really big optimization you can perform. And as well, I think Picasso is a little... it hasn't been super well maintained over the years. So that's something I definitely wanted to address with Coil. So I wanted to land somewhere in the middle with Coil, where I wanted something very simple, but also very performant and has feature parity with something like Glide. So I really wanted to double down on the simplicity. So Coil actually really only has 2 main methods that you have to understand to load in images.
That's a good segue, because that's exactly what I'm thinking, that most likely everyone who's listening is thinking is, okay, cool, sounds nice, but how do I use Coil if I want to load an image into an image view? Like, what does that process look like? And if there's 2 methods, what are those methods?
Definitely. So Coil is extremely easy to set up. So all you have to do is import the library, and that adds an extension function on image view called .load. So all you would have to do is you would do image view .load and then whatever piece of data you want to load. So for instance, like a URL or a URI, a file, an Android resource ID, anything like that. It's just one line, and it'll handle all of the lifecycle state, disk caching, memory caching, everything you would expect Glide to handle.
And it's interesting because also, like with most of these libraries, both Picasso and Glide, right? The API is really nice, but also almost all of these API, like in the way that I use them at least, right? It's like Glide with context dot blah 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 load this into image view with URL, right? So I think with the extension functions, and I'm sure like many people have written extension functions to just sort of like do this anyway, but it's just like worth calling that out, because I think that's like, yeah, in today's world really good, because in my usage with Glide, I've always noticed the same thing. I would have image view, I would get the context from the same image view, and then like really it's just the URL and the image view that really matter.
And I like the extension method on the image view, because this goes all the way back to when I started Android in 2008, 2009 times. Is I had an image view that I needed to load I had a URL that where the image was located, and I wanted to put it into that image view. But naturally, I was looking for a method that just allowed me to provide a URL, and it would just do it. And as we all know, that doesn't exist. So just that simple fact of having .load almost makes it kind of like a no-brainer, because it just, inside of the tooling, you can hit .load, type in your URL, paste in the URL, whatever it is from an API, and it loads the image in there. I think it's one of those things too that after you that I'm looking at the code now, after you get used to doing it, you almost feel like it's second nature, and you'll eventually forget what the original method of loading a image perhaps into an image view is, because it makes so much sense to do it the other way.
Yeah, that's true. Because otherwise it's, you have your image view, then it's set drawable or set source. And if it's from a URL, obviously it's not as simple, which is typically then why you would use like an image loading library or something, right? But actually, just to confirm that, Colin, load takes anything, right? It's not, because I keep calling it a URL, like an image URL, but is it smart enough to understand anything that I provide, like a source drawable, or vector drawable, or like a GIF image or something.
So it'll handle pretty much any type you would expect Glide to handle. As well, it has type-safe functions for this, the specific types it supports. So something currently when you load in with Glide, you kind of just pass it any object. It's not really type-safe, but I really wanted to show that no, like these are the types that are supported, so you know what you're getting yourself into. You mentioned GIFs as well. So this is something that Glide, it's not really supported by the Android system very well until Android P. But Glide supports GIF decoding out of the box. They kind of wrote their own GIF decoder, whereas Picasso doesn't support GIFs at all. Coil kind of takes a separate approach to this, where it has pluggable support for GIFs. So Coil's image pipeline is actually extremely extensible. It's made of 3 main parts, but it allows you to add support for custom file types fairly easily. So, for instance, if you wanted to write a progressive JPEG decoder, which is something not handled by the Android system, you could do that fairly easily and just add it into your image client when you're building it.
Can you also tell us what a progressive JPEG decoder is, or what a progressive JPEG is first, and then what the decoder is?
Definitely.
Well, let's start off with what is a progressive file, and then let's hop into the pipeline.
Sounds good. So a progressive JPEG is a kind of a specific variant of JPEG that allows you to load in kind of a rough, low detail version of JPEG, and as you're getting more image data, often from the network, it will appear to get more detail into the image as you load more from the network.
Do you know, I don't know the answer to this question. Is a progressive JPEG, is all that data stored in the JPEG, or is it just kind of figured out on the fly, or how's that formatted? Do you know?
I'm actually not sure off the top of my head. I think it's a specific format. Like you can't, you have to convert a JPEG into a progressive JPEG.
Okay.
There's, but I don't know the specifics.
It's okay. So that's a good kind of segue. We know that if you didn't have that progressive JPEG thing, like you said, and you wanted to build that in, you have enabled Coil to be very extensible. Before we hop into the image processing pipeline, can you tell us about the extension points that Coil provides?
For sure. So there are 3 main parts to what you can add to the pipeline. So there are mappers, which allow you to convert or decompose a bigger object into a type that's supported by Coil. So for instance, you might get a POJO from the server that has a URL inside it that you need to load. You can write a mapper that will map that data type into that URL. So you can directly pass that POJO you get from the server directly to Coil, and it'll handle it.
Oh, okay.
Then there's also something called fetchers. And fetchers are a little bit of glue that allows you to translate a piece of data into a buffered source. So a buffered source is an OKIO construct, but you can basically think of it like a buffered input stream. So for instance, Coil bundles, of course, URL fetchers as well as disk fetchers. So if you provided a file, it'll turn that into a buffered source. If you provide a URL, it'll turn that into a buffered source. But you could theoretically add your own for maybe something like protocol buffers if you would want.
Okay.
And that's super easy to set up. And then finally, probably the most important piece you can add to Coil is the decoder. So decoder is where it takes in that buffered source provided by a fetcher and converts it into a drawable. So this is how we can easily add support for GIFs, maybe TIFFs, animated WebP, pre-Android P, kind of anything you want, as long as you can read in the data from a buffered input stream and convert it into a drawable. You can write a decoder for it.
So that's pretty cool. I like how you've done that then, because if you've kind of created this framework for image loading that if for whatever reason, like you said, I want to use animated web Ps and it's not supported anywhere, well, I can just use Coil because it does all the other magic for me. I just need to write this other like kind of decoder to do it for me. And the other interesting part that you have here is actually the fetchers, because I at one point was talking to a consulting client who was building a piece of hardware. They had written their own custom like codec for streaming JPEGs from a camera source, and they needed to load it in at a particular frame rate, whatever. But it was just JPEGs, but it was a certain format. So considering that, and then there's a hook into Coil, it seems like I could write my own fetcher to then take that, decode it into their format, and then put it into an imagery or whatever. Would that be appropriate usage?
Yeah, I believe so. As well as something I wanted to mention is all mappers, fetchers, and decoders, they're very simple interfaces to implement. They all have, I think, roughly two methods, kind of handles. Can this accept this data type? And then you perform the operation. So they're very simple to implement.
Interesting. That's cool. One of the things I kind of want to rewind here, that something that you talked about that we glossed over here, was the concept of bitmap pooling. I wonder if you could explain what bitmap pooling is, why it's important, and why people might want to know about it.
Totally. So bitmap pooling is object pooling for bitmaps. So if you're not familiar with what object pooling is, it's reusing objects that you've previously instantiated after you know you're done with them. So for instance, I might, with array pooling, I might allocate, a huge array and then use it for whatever I need it for. And then when I'm done, I'll add it back to the pool. And then next time I need an array, I can call the pool and say, hey, do you have an array of this size? And it would give it back to me. So the same concept applies to bitmap pooling. And so for those who don't know, bitmaps are essentially big pieces of image data that are required to load in JPEGs and PNGs. They're kind of that image data in memory. And I'll say for modern Android versions, it often doesn't make sense to object pool, except for with bitmaps. And this is because bitmaps can often be huge pieces of memory. So a typical bitmap, if you're loading in an image, say at like 300 by 300, it can be kind of minimum a megabyte, all the way up to, if you're loading a 4K image into memory, that can take up 60 megabytes or so of memory, which is huge when you only have maybe 200 megabytes to work with. So reusing these objects is a huge performance benefit because it makes sure that that the Android garbage collector isn't constantly collecting these huge objects.
And like bitmaps basically are like the rawest form of data that you can have, right? It's funny because even when you think about JPEGs and a bunch of other formats, they're compressed image formats, right? Bitmaps are not compressed. Basically, that's the truest expansion of that image format. So like Colin was saying, when I worked at Wedding Party, this is something, unfortunately, at the time I had to deal with a lot. It sort of matters. You said 200 MB, Colin. This is because I think with applications, there is a restriction on how much memory you can use, right? Is that true, or is that why you said like 200 MB? Because like most phones have way more, right?
Yeah, I believe there's a restriction on each individual app. I don't know that a single app could kind of use up 4 gigabytes of memory, though I'm not 100% sure of that.
Yeah, and I definitely hope Android doesn't allow that for certain apps, because then it would go crazy.
So kind of want to, again, rewind just so we kind of understand some of the core concepts of Coil before we kind of go any more deeply into the system here. Mm-hmm. You had mentioned early on that coroutine support was something that you're interested in implementing and have implemented with Coil. If I load in an image, is there a way to cancel the loading of the image during, based, like you said, based upon the life cycle? Is that something that I can do manually? Does it happen automatically? Is there a way I can get a handle on it? What does that process look like?
Great question. So coroutines has really strong support for cancellation while you're performing operations. So you can cancel an in-flight request kind of anytime before it starts decoding, while it's midway through the network operation, anything like that. So whenever you start a request with Coil, it returns a request disposable, and that allows you to check, okay, is this request still in flight, as well as it allows you to cancel the request. Furthermore, Coil will automatically cancel requests to the same target. So for instance, if you're scrolling through a cycler view, it will cancel operations if the image view is detached or the lifecycle on destroy event happens, and you don't really need to worry about it.
Oh, interesting. So with the recycler view, that's a common use case, right? So say I have a recycler view with about 10 images, or actually, yeah, I'll say you have 100 images and you keep scrolling up and down. How does that work? Is there like some level of caching that's existent? Because say I scroll down and then 2 images basically we cancel, as you say, but then I scroll up and I don't want to like keep repeating these requests, right? How does that process work?
Definitely. So Coil keeps a disk cache for any images loaded from the network. And this is something actually that we get entirely for free by using OKHTTP. So it allows us to remove a lot of code that exists within Glide.
But if I wanted a custom cache, would you allow that, or no? Are we forced to just use because I don't? Yeah, how config? I guess OKHTTP's cache is configurable, but then I would have to do that at the OKHTTP layer, right? Which then means either I provide an independent OKHTTP client for Coil alone, or my global OKHTTP client already has a cache set, right? I may want for images, I might want a bigger cache or something.
Yeah, you can definitely control the size of the cache. I believe you can run custom cache implementations as well, though for this we actually just delegate directly to OKHTTP. So this has benefits as well in that you are able to add interceptors to any of the requests that Coil is making because Coil exposes its OKHTTP client directly. So anything you can do with OKHTTP, you can kind of layer on top of Coil.
So what are some things I would do with an image loading library with OKHTTP as an interceptor, right? Because I can think of it from a network perspective, but is there anything specific from like the image loading perspective that you think would be interesting there?
Potentially. So I think file headers is something that are pretty important, as well as you might want to potentially require higher TLS versions for more secure images you needed to load. And then
interesting, yeah.
I believe you could potentially control the dispatcher's implementation as well. Maybe you want to queue requests for a certain time. It's pretty open-ended.
I kind of want to understand the development use case here because as I've said before in other podcasts, I feel there's different types of developers. There's folks that like to build libraries such as that you're doing. There's also people like myself who I just love to build things like apps and so forth. And when I'm taking that into consideration, I think about, okay, this is a new image loading library. What are some of the things I need it to do? Sometimes I need a placeholder. Sometimes I need to turn that image into a circle. So in Picasso, I had some type of transformation I had to apply. Sometimes I need to do other stuff. And looking at the docs, it looks like some of the stuff is supported in Coil, but through like Lambda expressions or something. So I'm wondering if you could walk us through like some examples of, I need to load an image. You could say it's from a URL, and I need it to be a placeholder. There's transformations. Is there a way that I can show an error if the image download fails or anything like that?
Definitely. So Coil pretty much supports everything that Glide supports in its base request builder. So when you're building a Glide request and you say, glide.with .placeholder, then you provide the placeholder .error. Coil entirely supports that as well. The way Coil's API differs slightly is that so if you remember earlier when I mentioned the .load API, so the way Coil looks is if we want to perform this request with the placeholder and error on an image view, it would be image view .load, and then the URL. And then Coil's API provides a default Lambda param at the end. It's an inlined Lambda, so it doesn't have any runtime overhead, but it allows you to nicely configure the request if you want something that's non-default. So say you want this specific request to have a placeholder, you would add a Lambda param at the end of your load request to say placeholder, and then you would provide the placeholder. However, if you want to have a placeholder across all your image requests, you can configure the default options as well and have a default placeholder, default error drawable, and configure everything like that at a image loader level.
And this looks very, I guess this is like leveraging a lot of what Kotlin allows us to do today, right? And I mean, is there like, are you using some of the extension functions, like not extension, the DSL, the custom DSL stuff that Kotlin has here?
So it doesn't use any of the annotations to support DSL. I would say it's more kind of a builder behind the scenes. However, if you want to create your own value objects and pass them to Coil, it will handle that as well. You don't have to use the DSL API. Yeah.
Now, what about testing? Is a lot of times inside of my apps, I'll have maybe a recycler view or just some image that's loaded like an avatar, and I need to make sure that my image loading is working effectively. Does Coil support anything in regards to helping me with testing at all?
For sure. So testing was something that was super important for me. Definitely at Instacart, we've had our fair share of issues with screenshot testing because images haven't loaded in correctly or there's some kind of timing issue. I guess I haven't mentioned it so far, but Coil is built on top of something called an image loader. So an image loader, you can think of it a lot like your OKHTTP client. It's a service that takes in requests and executes them. So Coil is fully set up if you want to inject custom instances of image loader. However, if you don't want to do that as well and you just want a singleton, Coil has that. But image loader as well is an interface. It's not a concrete class. So you can, for your tests, you can write a fake image loader, for instance, that will always return the same drawable synchronously, which is really important for consistent rendering behavior and works really well for screenshot tests. Prevents you from having to deal with these timing issues of fetching stuff from the network. As well as like I mentioned, Coil is fully set up for dependency injection, which I think is a big departure from something like Glide and Picasso, where you have this forced singleton and you're not able to create and manage your own instances.
So let's talk about that for a quick second, because you mentioned that some time back, right? Because I'm thinking about how I typically use this. Say, you want for some reason 2 instances of Coil. Like initially looking at the API, it didn't look like that, because if I do an image view.load or something, then it's pretty much just that singleton Coil instance, right? But you're saying I don't have to use that. If I wanted, say I'm getting really good with my dependency injection, and for some reason I want one image client, the use case only that I can think of is like maybe this is like a secure image loading client or something, right? Like you have like sensitive information you want to load and you want to inject these in, like you want a different Coil instance to do the injection, right? Like I can't think of a good use case off the top of my head. Like say you don't want this ever to be cached. Like you want some information to never be cached. It's super sensitive, right? So I want a different Coil instance that loads the sensitive information without a cache. But I have this global singleton that does my regular icons and the other stuff I'm okay caching. How would I set that up? Because you said there's a Coil singleton instance, but you're saying you can also inject these manually into an application. Can you walk us through that?
Definitely. So in the default Coil artifact, it exposes a singleton. I realize I think most people want a singleton, especially for image loading. Glide uses a singleton, and it's just easier for migration purposes to have access to this singleton. However, I think injecting your image loaders and being able to scope them is probably the better architecture decision for larger apps. So that's why it's also supported.
Especially for testing, right? Like for testing, that
definitely
just makes it easier.
Yeah. But for testing as well, you can still replace the default instance. You can say, I want to use this specific image loader instance. So you can replace the singleton instance. I try to just support both as best as possible. And if you do not want the singleton, you can import the Coil base artifact, which only includes the image loader components without the singleton.
And this coil base, coil default artifacts that you're talking about are almost like modules, right? But in your Gradle import, you point to one of those depending on the one you want to use, the singleton.
Totally.
Okay, got it.
Yeah.
Now, there's one thing I saw I can't find it somewhere where I ever saw, but there's like these progressive placeholders where it will Coil will crossfade between lower and higher detail images. Can you tell me how that works? So I need two different images. Is this handled by the library automatically, or what is that entailed? So I can kind of get that nice, like, hey, there's an image here. It's not fully loaded. Now here's the crisp image. Is that the progressive JPEG you're talking about? Or am I asking like 12 questions?
And that's like actually a good point too. Sorry. Yeah, it's the same thing, right? Like so far what you've said, like it sounds that Coil is a great replacement, but what does Coil have that maybe other libraries don't, right? Like why would I take the trouble of using Coil? Like, are there any features? Like, I think this is one of them, right?
Definitely. Yeah. So it was very important for me to have a set of features that you could really only get with Coil. And this is partly supported by architectural decisions made internally in Coil. But so to start all the way back out, Coil keeps track of whether or not an image has been sampled when loading it from disk into memory. So this is common with image loading libraries where if you have, say, an image that's cached on disk and that image is, say, 1,000 by 1,000, but when you're loading it into your view is only 500 by 500, the image loading library, and Coil does this as well, will perform some scaling operations to only load the image in at 500 by 500 because this is a huge benefit for memory only having to store it in 500 by 500. So where Coil differs from other image loading applications or libraries is that it will keep track of this. And so say for instance, you have a master detail flow, you load your image in at a smaller size, and then you transition to the detail part of the master detail flow. And all of a sudden you need the same image, but you need it much bigger now because you have a bigger image view. Coil will intelligently and for free will use that smaller image that's still in the memory cache. It will use that as a placeholder for the bigger request. And it creates this really nice visual effect where it appears to be doing kind of the progressive JPEG thing where it synchronously shows the image at a lower detail. It's usually a little blurry, but it then fires off the request to load that image from disk at a bigger size. And you get this nice effect where it crossfades in the detail. And the best part of this as well is it's supported for all file types. It's file type agnostic, and it's also completely free, so you don't have to do anything in your API calls to support this.
That's very cool because I saw a animation of it that you had posted somewhere. Again, I can't find it. If I do, I'll put it in the show notes of that image loading. You would show the lower res looking version, and then it would just fade into the full one. It was a very nice effect, and it just felt very professional looking at that point because I felt like the user was given more feedback of like, hey, this is loading. I could tell something was probably still happening in the background, and then it faded in. So kudos on that one. One of the reasons why I like this library and I wanted to talk to you about it too is, like I said before, was a lot of the decisions that you made just made a lot of sense to me, like the image view.load, and then I could pass in a lambda to do crossfading and placeholders and all this other kind of stuff. And then what I learned about today, the extensibility kind of sets me up for the future. So if I've built an application, I'm using Coil, like I have this ability to extend in other things in the future, where if I've kind of gone with an existing solution that I may have used previously, I might not have that. And lastly, I just felt like it was easier to get up and running. But what I'm kind of leading up to here is like, all this is great, all this looks good, it sounds good, but what I really want to know is, has this been used in production at all? Has it been battle tested at all? And if so, would you mind sharing any of the information about that?
Definitely. So we're using it in production at Instacart. We haven't had any issues really, so I would say it's definitely battle tested as well. I'm using it in my personal projects. So it's definitely, I would say it's stable for use. I'm planning to release it at a 0.5 or maybe 0.8 potentially version. I think it's definitely stable for use. There might be small API changes still depending on feedback from the community, but it's absolutely stable for use.
That's cool. Awesome. That's super good to hear, because a lot of times you'll see libraries that are released and say, hey, this is really cool. And then you'll throw it in there into your application, and developing with it works great, but you'll push it out and all of a sudden crazy errors happen because it, again, hasn't been battle tested. But if it's been at Instacart, then I definitely know it's been strung through the ringer a little bit.
And Colin and I also had this conversation, right? I was like, dude, just release it as a 1.0, because it bugs me when libraries have a 0.5, 0.6, because it's almost like, oh, we're ready, but watch out for changes. And like, that's pretty much what I think it is. Like, we've using this is pretty stable. And even to Colin's point, the APIs, there might be some changes, but I think the APIs he's talking about are like maybe just some of the extensions, if at all, because the API in itself is super simple. There's just load and there's get, right? There isn't like pretty much anything. And I think that's a good thing. It's like super simple and dumb. Like, you don't need any other crazy, like fancy APIs. Like, it's an image loader. Just do the right things for me, like, because 80% of the time I just want like image loading to work a specific way, right? So I just want to bring that up. Like, even though Colin is releasing it as a 0.5, really, he should be pushing it as a 1.0.
It will hit 1.0 very, very soon after. I promise.
This is my indirect sort of coaxing, but yeah.
We'll just open a pull request and just push it to 1.0.
Maybe that's what we should do. I had a couple of follow-up questions, Colin. So the one thing when I've used Glide and Picasso, right, like the thing that annoys me a lot is like the whole scale type. And I don't know if you went into detail about this, but and like what I'm talking about is like, I have, from my days at Wedding Party, I remember I would want like the image view in certain cases to be like center cropped or like, fit. And I imagine all of those options are supported, but is there some kind of like detection that you do like to just do the right thing? Because it isn't too hard. Half the times what I want, right? If it's like a full screen thing, you basically want to fit it by width. If it's like by vertical, I know I want it to be fit like per screen or center cropped. Do you do any stuff like this? How do you do it? Can you talk a little about that?
Definitely, yeah. So Coil, this is kind of one of just the many quality of life improvements that Coil has. So it will automatically detect the scale type you need, or it's called scale in the code. If you think about scale type, it's really just a fit or fill scale with gravity. So we only really need two enums to represent it. So it'll automatically detect this. You don't have to worry about it. Coil just handles it. You don't have to call an extra API to say, okay, I'm gonna fit this image, fit center. It's handled automatically.
Fit XY, center crop. Yeah. Like I have center inside, at a certain point, I always have to pull that thing up to remember what they are. So you're saying it usually does it right?
It will do it 100% of the time right if you've set the scale type on your image view.
Nice. The other thing that I wanted to ask is, there are two methods: there's load and get, right? Another common use case that I typically would have is, and again, I'm trying to remember like in my like wedding party days, one thing we wanted to do is to give a much nicer